Hey students, in this notes we're going to go over how to solve quadratic inequalities that are two variables because they have the x and the y in the inequality given. So that means that we can graph them by the combination of points x and y, but we can use the technology to do it for us. So here's an example of a quadratic inequality. It looks like a quadratic equation graph, but then now we have a shaded region. So just like in Algebra 1, the order pairs, the x and the y values are the solutions if they are in the shaded area because they make the inequality true. So we're going to be seeing how to identify the solutions in this graphed inequality. The steps below are what's recommended for you to do this. So create a table of values. It is best to kind of look at the vertex and see where that turning point is at. Plot the points that you have. Determine whether the line is dashed or solid, and then shade either above or below the graph. This is the cheat chart that kind of organizes that for you. This is the same as Algebra 1. So here's 3 examples that show you how to do this. We're going to start by just either graphing by hand or graphing in the calculator. Let me adjust this for you a little bit. So we're going to graph this inequality right here. If you graph it with the equals, this is just going to show you the quadratic. So I'm just going to show you that. So I'm going to type it without changing the inequality symbol. I'm just going to type it as equals. And then that's what it should look like. If we graph it with the inequality though, it would have looked like this. We would have had to delete the equals and then it gives you the options. Or you could just go to relation and you will have to type the y and then the inequality symbol given. So both work, whether you select the option given or type it yourself. Let me just finish typing it. So it's the same graph, it's just this one is shaded. The difference too is that if you type it without relation, if you type it only on table, you could, not in table, on equation, you could get your table of values by pressing Control T, and then all those points on the graph are here on the table, so Control T. If you didn't have that, and you had relation, let me deactivate the graph. If we only had the relation graph, then we do Control T. Usually this doesn't appear if you don't have the equation graph. I just wanted to show you that, but it's not. So okay, so basically you just want to put this on your paper, and the way we'll do that is either by tracing the values, graph trace, and then just typing 1, enter, and plotting those points. So 1, -6, 2, enter, 2, -1, 3, enter, so 3, 2, 4, enter, 4, 3. Then just basically plotting points that we can plot on the grid given. 6, -1, and 7, -6. And then at 8 is too far below, so we'll leave it at that. It's also deciding whether you have a dashed or solid with this inequality symbol. Again, based on the notes, this symbol, it's a dashed line and it's shaded below because it's less than. You can also see this in the calculator that's graphed right here. If you press escape, so it won't trace anymore, and then just kind of run your cursor over it, you see a little dotted line. That means it's dashed, and then it's obviously shaded below because it's inside. If you didn't do relation though, and you did only function, Um, again, you cannot tell where to shade or whether there's dashed or solid. So just know the difference of how you're going to type it in. And of course, it will benefit you to graph it in relation more. All right, so with that, we're going to trace a dashed quadratic equation, and then we're going to shade inside of it. So this is the graph version of that quadratic inequality, and then now you need to check if 5, 8 is a solution. So 5, 8 will be right here. Because it is not in the shaded area, it will not be a solution. But in class, I also showed you can check if 5, 8 is a solution to the inequality by plugging in this 5 as an x and this 8 as a y. So you will be checking if y, meaning 8, is less than negative parentheses the x value, which is 5, minus 4 squared plus 3. You're going to check if this is true or not. So we can do it by hand, or you could also use it in your calculator and just double check. If you go to calculator and type that 8 less than negative parentheses 5 minus 4 squared plus 3. And then it says false, which means that this is not a solution because it's a false statement. So this is just another way to verify if the solution that they're asking is or is not a solution. And also this confirms that this point should not be in the shaded area, because if it was, then it would be a solution, it will be true, but it's false, so it's no. Okay, so let's try another example. Here's another one. I'm going to clear the calculator. And then I'm going to graph this one as an inequality already. So I'm going to press delete, and it gives me the options already of what graph to type. And then I'm going to type x squared plus 3x minus 18. And then it should look like that if I graph it here. So I can either go to table if I can. So let me show you, Control T. It tells you it's not going to work because there's no functions graphed. So in order for you to create a table, you will have to have typed it in function, which if you go to function, it's you typing it again, but it would have just been the graph without the shading part. But we can always trace as well. So menu, trace, graph trace. And then 0, negative 18 is the y-intercept. We cannot graph that, it's too low. I'm going to type 1, enter, and that's negative 14. Nope, 2, enter. Yep, that works. So 2, negative 8, 3, enter. We have 3, 0, and 4, enter, and that's 4, 10. Then 5 will be too high, so we're going to stop there. We can always go back to the other side. And let's see, negative 3, enter. Nope, negative 4, enter. Negative 5. So negative 5, negative 8 works. Negative 6, enter, that works. And negative 7, enter, and that works. So those are the points that I'm plotting. According to the inequality, we have a greater than, so that is dashed and shaded above. And then the graph confirms that. Again, press escape if you're still tracing and then run the cursor. Notice that this is dotted, so it's dash. So just dash it, and then it's turning somewhere down here, so I'm just going to assume that it turns. And there it is. So then we shade inside. And then we confirm if 2, -3 is a solution. So 2, -3 is right here. It does seem to be inside of the graph. I can just confirm once again by typing this is x and this is y in the inequality. So if I type for the y value we have right here, which is -3, inequality of greater than x squared, which means we're going to substitute in the x value we have right here. So that's 2 squared plus 3 parentheses 2, and then minus 18. So if I press enter, it says true. That means this point is in the shaded area. So we can say yes because it's in the shaded area, but also we can say yes because it's a true statement. So this is the reasoning as to why it is yes. Okay, next problem. I'm just going to speed through this one, so I'll clear it, and then we'll type it. So y, I'm going to delete it, and less than or equal to x squared minus x minus 6. All right, so to put that here, we're going to trace. So 0, -6 is the y-intercept. Then -1, -4, -2, 0, -3, +6, -4. That's too high. So then if we now go to 1 is -6, and then 2, -4. So it just kind of reflects all other points next to that. So the turning point has to happen like right here in the middle. And if I trace it, it tells me that it's at 0.5. So right here and right here. Oh, that symbol right there confirms that it's solid and it's below because it's less than. So that's the solid line behind it. And then less than will be shaded below. Okay, it's asking if -4, -2 is a solution. So -4, -2 is right here. It is in the shaded area, so it should be yes. But if you want to confirm why algebraically, you put this on the x and then this on the y in the inequality given, and then just check if it's true or false. So the y is -2. And then we have less than -4 squared minus -4 minus 6. So this is true, which means that that point is in the shaded area. And that's all it is. Just you having the skills of graphing an inequality, quadratic inequality, shading it in the correct area, identifying that the shaded area has the solution set, and also identifying that points on the solid line are solutions as well. So just be careful doing this by hand. You have your calculator available, but you can also do this by hand if you can.